From your data science experience, how would you quantify hallucination?
I think what's challenging is that at the moment, what we're doing is a lot of like benchmarking as it relates to AI models.
If a company is deploying AI in production today, what would your 2026 hallucination mitigation checklist include?
Building out that process there's a couple different ways.
What's the single most important piece of advice you'd give about building trustworthy, reliable AI systems? Hey everybody, welcome to another episode of PureLogics Pulse, a podcast powered by PureLogics, where we explore technology trends, product innovation, and digital transformation. PureLogics is a full-service technology partner helping enterprises and startups drive digital transformation, build next-generation software products, and scale AI solutions that create a real business impact. I'm Mohsin Ali, and I spearhead AI initiatives here at PureLogics, where I work across product, engineering, and enterprise clients to turn AI from experimentation into production scale impact. 2026 has started, and there is a buzz around AI agents and proactive AI systems. But right now, one of the biggest problems with AI systems is hallucination. Is 2026 the year AI hallucinations can finally end? To discuss this, I have Ian Garrett with me. He has been in the technology industry for more than a decade. He has designed and evaluated machine learning models throughout his career. And right now, he is the CEO and co founder of SendTurtle, an AI based document intelligence platform. So, if you're going to deploy AI in production this year, listen till the end because we are going to discuss non negotiable safeguards and how to manage hallucinations effectively. First, Ian, do you think 2026 can be the year that AI hallucinations end?
For one, thanks for having me on. Always glad to share some insights. And yeah, I absolutely think that 2026 can be the year to reduce the amount of hallucinations, or honestly find a way to, to have the true safeguards to fully eliminate it, depending on the use case.
Absolutely. So, diving deeper into that, how do you personally define AI hallucinations and why do they matter for enterprises adopting generative AI?
Yes, so the thing about hallucinations is for one, it's when a model will, and particularly it's associated with LLMs or generative AI, when it produces something that sounds like a correct answer, but is not necessarily, it's potentially made up. So the kind of use cases that often get in the news is when someone will ask a LLM to, let's say generate some research, and then produces research publications that don't exist, either with the correct author, with publications they never did, or just makes up some authors. So that's in general what a hallucination would look like in that kind of setting. Obviously, there's a million different examples, but ultimately it comes down to, hey, it's producing something that sounds like a legitimate answer to the untrained eye, but if you dig into it, it actually is completely made up.
Absolutely. And that something generating facts that are not steeped in reality is such a slippery slope. Diving deeper into the architecture side of things, are hallucinations primarily a training data problem, or is this more about the structural limitations of the models themselves?
So I think then maybe this is controversial, but a lot of people I think would normally say, hey, this is a training data issue. There wasn't enough training data, or it was trained on incorrect, either incorrectly labeled or however else, depending on your data sets. But the reality is that in like technically, when a model is hallucinating, it is doing what it's supposed to do. So like a generative AI model isn't necessarily, so if when it's doing what it's supposed to do, it isn't necessarily right. It's just trained to sound right. So it wants to sound as confident as possible. It's pretty much trained against saying, I don't know. So it's going to tell you, in its purest form, it's going to tell you whatever it can that sounds as legitimate as possible. Um, Particularly because, the whole premise is that it's predicting what's supposed to be the next step. So ultimately, it's like, hey, if I don't have a high confidence, I'm going to toss something out there, And again, it comes back to the people reading it to say, hey, is is its prediction of the next word a legitimate one, or did it just make something up? So, I think it's not really a training data problem. I think it's more so as we develop the systems, adding honestly a layer of inefficiencies on top of the models to make sure that it's doing what it's supposed to do, that it's okay to say, I don't know, is a big one. And then it's has safeguards so that, when it says I don't know, it doesn't just, its next step isn't to say, hey, here's something I made up that sounds good. Instead, it's here's my, I don't know it, or let me go into another process. So that's kind of where you can bring in maybe agentic AI. It's like, hey, I can't do it here, but this other model can train is it trained on something else that can handle it.
Absolutely. And there's so many directions we could take this conversation into, so many interesting points. It kind of reminds me, your suggestion reminds me of GANs, generative adversarial networks. So the adversarial part is defined to keep the generative part in check. So maybe we could go into hybrids that perform these sort of functions. That's a very interesting concept. And when we talk about oversight, it leads us very nicely into our next question. So in traditional systems where we work with cybersecurity or defense system, we validate each output against a known ground truth. How does that compare to training the LLMs today?
Yeah, so I think it's pretty much very important to do the same. So it all comes down to what's your use case. And I think part of it too is a lot of people want just, one easy button, one portal that they can go to that does everything for them. But, even as we know, as humans, the more generalized you are, the less you can do any particular task in a specialized manner. It's just it is what it is. That's how it works. Um, so in a similar sense, like the more generalized the model can be, the more potential errors, and the less you can really deep dive with it. Not to say it's impossible, but truly even if you think about for the commercial models that exist for LLMs, you can perform some RAG and have documents that you upload. Even in that specific case, you're saying, hey, even though this model can be generalized, I want it to be specific to these documents in this context. So even in that case, we're funneling down the large model into a more specialized model.
Absolutely, and it sounds counterintuitive to have a global model that's limited to a very small data set. So I can understand the challenges that come with it when refining the model or when closing the model within certain boundaries. Um, so moving into a bigger picture view of things, talking about the hype of AI, how has the bar for AI reliability shifted over the last year? And what does that mean for teams building AI powered products?
Yeah, so and as someone who's been in the field for a while, it's funny now being in this place where we can just use the word AI. Before, it wasn't specific enough because there's so many things that fell under the umbrella of AI. But in generally when people are, or at least enterprises are talking AI these days, it is a mix of a lot of the technologies that they've already have. So, and then again, this is also potentially contested depending on how people want to define AI. But, I think of it more of an umbrella where you have machine learning that fits under there, but potentially some automation that isn't, super smart. But I think a level of automation still can fall under there. Um, and then, all the big data, the analytics, like that again isn't smart from that perspective, but I do think it's very important to consider how big data, automation, and machine learning play together to build this holistic, AI system. So, as we're moving into 2026 and beyond, and AI adoption is becoming more popular, I think kind of the biggest danger is for it's like a pendulum swing. So you see like especially from larger organizations, a lot of resistance, and then they'll see smaller organizations adapt well to AI adoption, and they go like, we need to toss some AI on it, or like let's use AI internally, and then it'll swing the other way, and then you have people that don't truly understand how to use the technology correctly will just absolutely just trust it 100%. Like the people that were trusting it 0% now trust it 100%. And the reality is you can't do either. You want to be somewhere in the middle. Because if you do 100%, then you have, the consultants delivering hallucinations to clients. Or you have engineers delivering, securely riddled vibe coded applications, into production. So like that's the challenge of 100%, and then 0% is then you're losing out on, tons of productivity. So ultimately, especially the larger organizations, it really needs to find a way to, as they're bringing it into their processes, teach people to not fully trust it, but also trust it enough to gain productivity bonuses.
Absolutely. And since AI has become the part of every company's value proposition, more and more companies are shifting to AI. Now, the problem from a sales and engineering combination perspective is the salespeople aren't technical enough to understand the engineering side, and the engineering side don't have the commercial value in mind when they're building or recommended systems. That's definitely a challenge. And it's interesting to see in the past 2 or 3 years the evolution of demand from going from data engineer or data scientist requirements to full stack AI engineer requirements. And the danger that we find ourselves in is giving specific solutions in the hands of general engineers. That's something I've noticed in my experience over the past couple of years. So moving on,
Yeah, I mean
quantifying.
it. I
Yeah.
think it's an interesting thing because also if you remember back in like 2021-ish, like when ChatGPT was just taken off. So obviously OpenAI had their models prior to Chat, but Chat was released and then all of a sudden people paid attention. But what you saw was a rise in a job called prompt engineering, like prompt engineers. And these were like, 250K plus in the US jobs. And you're just like, what in the world's it like, what exactly is this job? And then you'd have people that would have like, oh, you need like 5 years of prompt engineering experience, and it's like, well, I don't
They
know
didn't
who has
exist.
that. Like, it's like, do you need people who know how to like build ML models or like, but you don't see that anymore, right? So like, at least for the most part, I haven't seen a prompt engineer job description float around in a couple years. So I think people are still trying to figure out what does engineering in an AI world look like, um, because it falls into like, so yeah, you have your full, let's say you have your full stack engineers very capable of doing a lot of things, obviously writing code, but as a full stack engineer, more often than not, you're doing a lot of just making sure things talk to each other correctly and plugging things together. And if you're leveraging these models, it kind of looks like that. It's like, yeah, there is data pipelines you have to deal with. Yeah, there are models there, but for the most part, a lot of it is a black box to these engineers. They don't fully understand how it works behind the scenes, but they also kind of don't have to, and that's like part of the benefit. So from their perspective, it's not different. It's just another tool that they need to integrate into the platform. So like if you're needing that, then I think a generally full stack engineer for the most part is fully capable of doing that. But if you are doing custom models, then yeah, like they have the coding, expertise to do it, but that's not really the full scope of the job. Like, so if anything,
Absolutely.
you'd need to pair them with a machine learning engineer that knows at least the models, or possibly a data scientist. Um, but yeah, so it's like you have on the one side of the spectrum people that are heavily users, and that's where those prompt engineers were. I think that's where vibe coders are. And then kind of in the middle, you have like like software engineers that can make the systems work, and then on the other end you have like machine learning engineers, you have data scientists, like people who knows how the actual models work, that maybe don't have as strong of a coding background but can actually get the thing to do what, specifically what you want to do. And then so when someone says AI engineering, I what I think is like, which part of the spectrum are you looking for? Like, what exactly is the task you're trying to do? Because you have everyone from I can use AI tools really well to I know how AI actually works to like I know how to actually connect the systems together.
Absolutely. And this has been such an insightful answer for me. I haven't been able to define it in as articulately as you have. That's much more clearer that we're dealing with AI as black boxes in some cases where we could define a full stack AI engineer, let's say, and
Mhm.
we're dealing with the intricacies of the AI model itself where we need specialists to handle it. Beautifully articulated, Ian. Come back to the topic a little bit. Um, Talking about hallucinations in AI systems, from your data science experience, how would you quantify hallucinations?
Yeah, so I mean, it is a little more difficult than your in other fields, right? So, let's say for software engineering, you got unit tests, and it's like, hey, is the thing working or is it not working? You briefly mentioned cybersecurity, which is another key part of my background. But in those cases, yeah, there are false positives, but there is a ground truth that you ultimately are able to. Um, Go back to. So in this case, I think you want to take that type of approach to building a quantification around it. I think what's challenging is that at the moment, what we're doing is a lot of like benchmarking as it relates to AI models, which is okay. But I think it doesn't fully encompass like the true use case. So I think maybe start with what a benchmark would look like, but then you really need to tailor it to the specific use case it's being used for, particularly, if it's in a certain industry, and then have a set of ground truth to be able to base it off of and use cases. Because like at the end of the day, if you're benchmarking on how well this model can write essays, but it's what it's really doing on a day-to-day basis is looking for network anomalies, then yeah, the benchmark might be good, but it might be garbage at the actual task that you're trying to have it do. So I think it's just like take the concept of again taking the more generalized, larger piece, finding the version of it that you need it for, and then that does require work, right? It takes and then benchmark it against your specific use cases.
I think that's a very nice strategy, a multi-layered benchmarking system that's suited to your needs. Very interesting concept, Ian. Talking from one enthusiast to another, uh, I've seen examples of language generation system that use chain of thought prompting to correct the output itself or to keep it in check in order to
Mhm.
establish a ground truth for what it asked for and what it delivered. There are so many interesting concepts that are available for everyone to explore in 2026. I think it's a very interesting topic. Um, Going back to how to arrest hallucinations, guardrails are such an important part of every AI application. What has your experience been in designing these guardrails?
Yeah, so I think that goes more into confidence levels. So, um, there's a lot of different models that work by essentially producing confidence levels. Um, and this is when you're dealing with generative AI or LLMs, it's not any different. And so what I think is important is understanding like that piece of it, because if you're able to put in a threshold that is not acceptable, I think that's important. So like a generalized, commercial, I go online and prompt engineer, or put in a prompt. There's not the ability to say, and if you don't believe, if you don't have confidence over X, then don't give me an answer, or go figure it out until you do. Um, but I think as you're building out custom models, like that is something you can absolutely put in as a guardrail because I mean ultimately again it's not different than what we've done and seen in the past with automation and less generative style models, but you absolutely can apply it. Ultimately, I think if we can put in saying, hey, if you can't tell me with a 98% confidence that this thing is legit, then I don't want it. That could be a very important, or you could even be 70%. Like again, depends on the use case. Some are more, again, going back to essay writing. If you're writing something that's kind of like for fun or some creative, like hey, you don't need it to be a high confidence. You just need it to spit out something because or hey, that you're using for brainstorming, just spit out some stuff. Like let's do some back and forth. Just tell me some stuff. Maybe it'll trigger something in my mind. But if you're using it for determining like medical records, like I'm gonna go ahead and want that to be very accurate, and I want to know if you don't know it, that's fine. I'll go do it myself. But because ultimately, let's say it is medical records or something like that. Um, let's say you have 1,000 and it can handle 800 of them with a 99% confidence, and 200 of them it can't. It's like if you can reduce a doctor's workload from 1,000 to 200 or 100 to 20 or whatever, that's a huge improvement in productivity. And you're not worried about those 20% being, like potentially doing some harm via not having a high enough accuracy.
Absolutely, and that's such an important way to understand things. It's a probabilistic model. It's going to give you the most likely estimate, not the certain estimate. So we have to keep that in mind as developers and as product owners. Uh, we get caught up in the hype, we get caught up in the sales pitches, and then we deliver something that builds an expectation at the user end. And then when it's discovered, it's a long cycle of revisions for the company that delivered the solution. So, but it's a very interesting insight. Um, Going back to a more strategic discussion, if a company is deploying AI in production today, what would your 2026 hallucination mitigation checklist include?
Yeah, so honestly, it goes back to similar what you mentioned about the adversarial networks, which is a topic near and dear to my heart. But yes, I mean, essentially building out that process in there's a couple different ways. I mean, you could do it obviously formally, and depending on what kind of model you're using, there's a number of models that build in that like actor critic type um, model into it. But let's say you're even just using a regular prompt. There's actually a number of methods that you can bring in the style of an adversarial network without actually implementing one, which is um, being able to, ask whatever question or task that you're having it do, but then have it do follow-up validation on itself. So again, from a very simple use case. Let's say I'm asking a question about how to repair my car. So let's say, hey, like how do I fix this one thing on my car? And then part of that would be, normally I'll just you could just put that in and it'll give you something out, and then you go out and you have to figure it out. But instead of just doing that, you can say, how do I fix this part of my car? And then come up with 2 to 3 questions that pokes holes in what you just gave me, and then answer, in the perspective of those holes that you poked in your own answer. Go back and give me a better answer that addresses those. And then what if you do that process? At least I found it to be very effective in reducing hallucinations because if it actually builds a safeguard into itself, that's done completely via commercial prompting. It's not, you don't have to do anything custom. And then but at the higher level or enterprise level, building that process essentially into the models. And again, there are actual legitimate peer-reviewed papers on how to do that. Which again, it's not a new concept, but it is something I think as people are moving, as we're maturing away from pure Wild West of like, what is this thing even capable of, to okay, now we know it has capability. How do we increase its ability to um, be more correct? And so, I think that's one way to do. I think the other way, just is as the models get better, as the systems get better, as the context windows get larger, like as the, models have more complexity built into them, I think that also will help. But ultimately, yeah, I think just always building with the validation in mind will help you at no matter how advanced or how unadvanced or advanced the model is, it'll improve accuracy, you know, either way.
Absolutely. And if you can contextualize the latency demands of your application, automated reasoning is, in fact, a very go-to strategy for all of the AI product developers out there. So, excellent recommendation, Ian. I think you've articulated it in a very expert manner. Now, the
Appreciate
focus seems to be shifting from eliminating hallucinations altogether to managing their impact. Is this the right strategy, or are we accepting limitations we shouldn't? Expanding on that a little bit, as LLMs become much more capable black boxes, the building of LLM applications is starting to resemble traditional deep learning. So, from that perspective, when we used to encounter a challenge in deep learning, our answer was to try to fix it. Are we accepting the limitations in this case?
I think the biggest challenge in the difference between how we're approaching LLMs and more traditional deep learning is that at the core, when you were building out a deep learning system, you had more control over everything. So, and as with anything else, especially the most important part about a model is the data that it's being trained on. Um, so, in a lot of traditional deep learning, you like the barrier to entry was you had a data scientist ensuring the data was clean and then building a model based off of that data and then producing, the outputs that then went to whatever it was doing. I think the challenge with LLMs in its more accessible state is that the first two parts turn into a black box for a lot of teams. So they don't know what data, like how it was trained, what it was trained on. There's less control over that. It's a little less structured, which on the one hand is amazing, right? Like the fact that we can add more and more unstructured data and draw insights from it and use it for training is incredible. Um, but as more of that gets abstracted away, it becomes less of a ability to eliminate and fix because you can't do it. You have no control over it. But even let's say you have a localized model that you do have a little bit more control over. Um, then it goes into what is the resources to actually handle it because like obviously this is exactly counter to what I said earlier, but the more inefficiencies you add, then at some point you need to figure out what are we actually doing, because if you add enough inefficiencies in to make it accurate enough, I think most people will find that LLM wasn't the right tool. Like, there was actually a better tool out there to use for your use case, and it was an LLM or generative AI. So I think that's the other piece too, is that when it's you put the generative AI glasses on and everything looks like generative AI, the reality is a lot of solutions can be solved with just pure automation, like just not no AI, like no machine learning, just as AI in its like most simple form, where it's just like automation. So again, I think managing it, if it's the right tool, is probably your best balance between the efficiencies you get from the productivity, but also, the inefficiencies you have to add in to make it accurate. But before you even do that, I think the big question is, what is the right tool to actually apply for my use case? And is it an LLM or generative AI to begin with, or is there a better AI model or other method that makes it a lot better? Because I mean, at the end of the day, um, you know, engineers will look at like a solution and say like I can build I can build this. Um, and someone who isn't necessarily engineering will like, oh, I can just AI produce that. And I think there is a time and place, but like for example, let's say prototyping. I think prototyping is a great use case where it's like, hey, it could be kind of janky, but we're just trying to do a proof of concept. But like production level code, like I don't know. There's there's definitely ways to use it in that is absolutely going to work and help, but I think a lot of people talk about it like, hey, I just press the button, I walk away, and it's going to do everything I need for production level code. And at least in today's world, 2026 in January, um, who's to say what the later in the year is going to hold? But at least right now, in this moment, that isn't the case.
Absolutely. I can't tell you how many POCs I've seen that have been developed using anti-gravity or cursor, and I've been able to spot the ridges. So when we're scaling AI systems built on a POC vision, a previous guest on the podcast described it very eloquently. It's like zooming into a pixelated image. Any gap that you'd see zoomed out is magnified, and each fracture becomes a rift. So that's when you scale POCs irresponsibly. You've articulated it in a very nice fashion. You've captured the concept in a very nice manner. Um, Going back to advice for the community, the utility of AI seems to lean more towards POCs, and there is a responsibility for each developer to provide the oversight on the processes that we're integrating into the POCs. Could you speak more to that?
Yeah, so I would say again in January of 2026, it's not the time to lay off all your engineers and call it a day. But I do think you can increase the efficiency of each engineer. So, like I absolutely believe that. So there's a lot of engineering tasks to include looking stuff up or documentation, like in understanding documentation before you can actually write the proper code that you need for whatever application. Um, and just a lot of like not difficult but repetitive tasks that I think absolutely can be farmed out to your AI agents in a way that is not harmful to the solution, is not overly complicated in terms of, it's not producing a bunch of code that people don't understand how it works. Um, but that absolutely can increase productivity, can push product much faster. But also, I think it goes back to, use cases. So there's a time and a place for POCs or prototypes, and there's a time and place for like a true lockdown enterprise solution. But like if you really nail down when is it acceptable for each one, I think that'll help a lot. So, for example, someone is interested in starting a new product, a new product startup, and wants to launch to market. The process of going to market requires so much experimentation in do people even care about like what I've built? That's why they always talk about the minimal viable product because it's like you don't want to overbuild. Um, so, being able to use AI systems to create a prototype essentially of that MVP that people can actually touch and feel, um, is a huge leg up because it used to be, you would go through this process, but it would be a bunch of, mock-ups. It'd be a bunch of mock-ups. Hey, this is what it's gonna look like. This is what do you think about this? What do you think about this? But being able to push out a prototype and saying like, hey, this is it. There's gonna be some bugs maybe, but this is generally, is this solving your solution or your problem? That's huge because then, you get a certain level of traction. And then it's like, okay, I have the framework of how I have like the how this thing is going to work, and I have the feasibility. So from an engineering standpoint, I know it's going to work. Now I just need to go back and build it correctly. And that's a way easier problem to solve than starting at ground zero and you go, how do I even get this thing to work and do people even care? Like if you get the how and the do people even care, then all you have to do is just build it in a good way. Essentially, just following what you just did, what the AI had built for your prototype, and just plugging the gaps to make sure it's smoothed over.
That's such an interesting way to put it. Generating the roadmap to an actual scalable product through AI and actually implementing it yourself seems to be a much more tractable way to produce the applications at a
Yeah.
much more reliable pace. So, just closing the argument or the closing the podcast with some insight from you. For teams and leaders navigating the AI adoption this year, what's the single most important piece of advice you'd give about building trustworthy, reliable AI systems?
Yeah, I think it goes back to determine what do you need. Like figure out what do you actually need the AI for. And if it's just for because we need it or because we're supposed to have it, like then you don't need it. And that really goes for everyone. I think what's challenging the conversation is that everyone's rushing to an AI hype where it's everywhere. It's, there's a lot of it that's not helping anybody. It's just existing. So it floods the market in a way that it's hard to navigate what matters, what doesn't matter. And then it only adds, you know, problems. So whether that's security vulnerabilities, whether that's, hallucinations causing issues or, it performing in a way that for example, the AI customer support chatbots that were incorrectly issuing credits and like stuff like that. And it's all because it's a rush, right? It's a rush to get it to market. So I think really the first step before anyone should talk about implementing any AI systems is to take a step back and figure out like what truly is the problem we're trying to solve. And of the tools that we have for that, if the answer is still AI, what is the right AI to actually implement here? And then the kind of last possible right answer is let's just slap an LLM on it.
Absolutely. And as we wrap things up, one thing is clear. Understanding the problem is 50% of the fix or the solution that you're going to be providing. And time to market is not your only advantage. A reliable AI system might be a much better competitive advantage moving into 2026. For all the data science enthusiasts out there, we've been seeing a pendulum effect, like Ian mentioned, in the AI adoption side of things. It's orthogonal matching pursuit in action in the market. If you get my reference, please comment below. Thank you so much, Ian, for joining us. Thank you so much for your expert insight. It's been a gold mine of insights for me.
Yeah, really appreciate you having me on. Super happy to share insights, and I hope you have a great one.
Thank you, Ian.